Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Alright, so moving on, we have port numbers. So both TCP and UDP use port numbers for establishing of sessions. The port numbers are used to manage multiple simultaneous conversations. The source port number is associated with the originating application on the local host. The destination port number is associated with the destination application on the remote host. Oftentimes, the destination port is the one that is most critical. So, what is a socket pair? A socket pair is when you're dealing with the source and destination ports are placed within the segment. The segments are encapsulated with an IP packet. The combination of the source IP address and the source port number is known as a socket. The destination IP and the destination port number are also known as a socket. So the socket pairs are dealing with the source and destination ports. Again, the destination port is the one that is most critical. The destination port allows you to know what service you are requesting. If you're dealing with port 80 or port 443, you know those are well-known ports, port 80 being HTTP, port 443 being HTTPS. I said well-known ports because there are different groups of port numbers. Port numbers are broken down into 3 groups: well-known, registered, and dynamic. Well-known are any ports between 0 and 1023. Registered ports are between 1024 and 49,151, while dynamic ports are 49,152 to 65,535. Well-known ports are the ones that are well established. These are going to be the ones that are predefined and are pretty common. A lot of services like Xbox or PlayStation chat communication are going to be between the registered and the dynamic port ranges. What are some port numbers that you should know? Things like TCP port 20, 21, 22. 22 is SSH, 23 is Telnets. 53, both UDP and TCP are DNS. If we're talking sending email, that's going to be TCP port 25. You need to know port 80 and 443, that's HTTP and HTTPS. If we're looking at receiving email, that's going to be port TCP 110. For IMAP, again, still receiving email, just a different type, different way, is going to be TCP port 143. These are not all of these. These are a very small collection of port numbers that you should know. As you develop more networking skills and you have been a networking technician for a long period of time, you will slowly start to memorize the most common ports. These ports allow for end communication. How do you know if the ports are open and allowing established connections? We can do a netstat command on a end device at a command terminal, and that will tell you the local and foreign address and the state. You can actually implement switches with this netstat command to see what port numbers they're communicating on if you wish. Again, outside the scope of this video, but you can. So how does TCP communicate actually work? Well, first of all, an individual server cannot have 2 services assigned to the same port number. While a server can host multiple services, each service will listen on their dedicated port number. If we are listening on port 25 or on port 80, we should know that port 80 is basic web traffic. We should know port 25 is for SMTP. That's for sending email. This allows us to kind of understand what services that server is actually serving. Any incoming client request addressed to the correct socket will be accepted, and the application server will process accordingly. There is a session connection with TCP. Basically, you establish the connection. You do this with a 3-step handshake. First, the initiating client will request a client-to-server communication session that will send a sync requests. The server will receive the sync requests and will send an acknowledgement to the client-to-server communication session, and it will request a server-to-client communication session. The destination will send a sync and a ACK. The ACK will be basically the sync number plus 1. It will then generate a sync number. The original sender will receive the sync acknowledgement, and then it will initiate a client acknowledgement to the server-to-client communication session. The acknowledgement that it received will now be set to the same sequence number. It will set a sequence number of, again, these numbers are randomly generated, so whatever the sequence number begins with, that is where you'll start building the acknowledgement numbers from. The sequence number will be 1 plus the acknowledgement, and then you will have an acknowledged number, which will be 1 plus the sequence number, and that is sent back to the receiver. That way, the receiver now understands there is an agreed upon session. This is to begin the session. To terminate a session, the receiver will send a FIN. The receiver should receive it. They will send an acknowledgement and a FIN of their own. Then the original sender will send an acknowledgement, and then the termination will be terminated. This is known as the 3-way handshake for starting a communication. Again, it will establish that the destination device is present on the network. It will verify that they're active on the service and that they're ready to receive communication. The 3-way handshake actually will be sending data in the control bits. There are 6 control bit flags. There's an urgent flag, an acknowledgement flag, a push function, a reset function, a sync function, and a fin or finish function. These are also types of flags that are seen when there are certain types of network reconnaissance going underway. I've posted other videos for the 3-way handshake. Please review those videos. If you need the link, leave a comment and I will get you those videos. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.